All right, so in this next little world we're going to be introducing some new ideas and talk about why we need different types of perspective. The beginning is pretty much still the same, okay? You need to know where your eye level is. I'm going to put the eye level 1 inch from the bottom of the page, so it's a really high eye level. We're going to be looking down into this world. To be honest, it might be better if it's even a little bit lower, because then we can draw some things above it. Should we do that? Let's do that. I'm going to put the eye level right in the middle of my page. Sorry.
Oh.
So I'm going to come down like 4 inches. 1, 2, 3, 4.
Can we do that as well?
Yeah, why don't we do that? It doesn't matter. The logic still applies. But if it helps you to follow along, I'm just going to lower the eye level a little bit. And then on this drawing, I've got to extend my eye level off of this page. Okay, I'm going to zoom out a little bit. You'll see why. And if it helps, I highly recommend labeling things so you remember what they are and what they mean. What I'm saying is this is my eye level. And in most situations in perspective, in 1 and 2 point perspective, the eye level and the horizon line are exactly the same thing. That's not always true, but most of the time it's true. Okay. The next thing I need, so I've figured out my this x-axis, I guess, right? We also need our vertical line that represents our line of sight, so we know where we're standing. I'm just going to use the top of my page here in a triangle and draw a vertical line. And I'm going to draw it off the page as well, okay? And what this means, okay, I've used Mr. Incredible here, but what we're saying is this figure viewing this world is viewing it from this point. This is their point of view. So everything moving this way is moving to the left, moving to the right, moving up, moving down. Okay? This is the point of view or the perspective that we're creating this world. Okay? The other variable, the z-axis, represents how far away this person is, right? And why is it better to be a little further away? Do you remember this, Caden, when we took that photo? Why do we want to back up a little bit? What happens when you get really close to an object? Things get distorted. And that's why I wanted to go off my page a little bit. I'm basically saying I'm going to move Mr. Incredible back this far. So I'm putting the station point here, but it really means that I'm just saying that he's this far away. When I put that station point, you can just take that distance, bring it up, and we're saying this is where we're viewing this world from. Does that make sense? Yeah. Okay. And you'll see why that's important in a minute. So far, this is just review. We're just establishing where we are, where we're seeing this from. You can add this cone of vision. Just remember, this is the cone of vision. It's not measuring lines. It's not vanishing points. It's just that when you're viewing a world, like if I put his head right here, everything that he's looking at, everything inside of this, he's going to see clearly. Everything outside of that is getting distorted and blurry and wonky. Does that make sense? Okay. So, all right. So station point, and then I'm going to label this COV, cone of vision, just so I remember that these are not the lines I'm using to draw. This is just, I want to keep my drawing inside of this if I can. Okay. So, in 1 point perspective, everybody watch this for a minute. Just take a break from wherever you're at. the ideas here are more important than the drawing, okay? 1 point perspective works when you're facing an object, right? So if we were looking at a map and you're just looking straight down and you're looking at the front of an object like this, when you take that into perspective, that's 1 point perspective. And what happens is all these lines that are moving away, we call them orthogonal lines, they appear to converge at a vanishing point, right? And so 1 point perspective works great for that, okay? Problem is sometimes in life, you're not facing the object. The object is twisted. And so the second we rotate that object, it's no longer a 1 point perspective problem. Because you see, we've got sides moving this way, and then we have sides moving this way, visually, right? And so some fundamental truths that you have to keep in mind. First of all, if you're looking at this top plane where I've drawn these lines, at the eye level, you can't even see it, right? If our eye level is right at the level of the top of the box, but as we move the box lower and lower and lower, we start to see more and more. And the station point is the point at which it becomes a perfect square, theoretically, right? So with that in mind, when we're drawing, say I just kind of look at an object and I kind of see approximately where it's going, and I'm arbitrarily drawing a vanishing point right here, and I'm going to number it vanishing point 1. Okay? That's not too complicated, right? There's my first vanishing point. But what you need to know in order to do these drawings is I can't just arbitrarily decide where the second vanishing point is. Okay? Because at the station point, what's going to happen is the first vanishing point is always going to be at a right angle to the second vanishing point. Does that make sense? So you have to know your station point. And so I've got a triangle here. So if I go at a right angle from my vanishing point to my station point, where that intersects is where my second vanishing point will be. Does that idea make sense? They're always at a right angle. Would it help if I drew that down here? And not that you need to do this for today, but like I could rotate. Right now I'm saying my box is in this rotation. I can rotate it. I can move it a little more. Then my new vanishing point's there, but look what happens to that vanishing point over here, right? They move in relationship to each other. Does that make sense? Maybe, maybe not. We're gonna have some time to wrap our brains around this. Just trust me for now. Draw a vanishing point on the right side of your paper somewhere, and then figure out where the other vanishing point is. It's not going to be on your page, okay? The only way it would be on your page is if you moved in your station point really close. And the problem with that is your cone of vision's really small, and then you can only draw a teeny little drawing, right? So you want to have your station point as far away as reasonably. Does that make sense? Okay. So what I want you to do, let's get everybody this far. So step 1 is eye level. Step 2 is line of sight. Step 3 is station point. Step 4, cone of vision. Step 5, VP1. Step 6, VP2. Okay. And just remember that these two have to be 90 degrees apart from the station point. So this angle between this and this has to be a right angle, 90 degrees.